Hello everyone, in this video I'm going to be showing you how to factor out a GCF, or a greatest common factor. If you want a little more detail on how to find a greatest common factor, you'll have to watch the previous video. So here we're going to do three examples. So let's take a look at the first example. 40x squared plus 72x plus 64. So what we need to do first is identify whether or not there is a GCF. And what I do and ask myself to see that is, can 40, 72, and 64 be divided by a common number evenly? And they can. So I'm going to find that greatest number. Again, if you want to know how to find that GCF, that was in the previous video. Here, I can recognize 8 as being the greatest common factor. 40, 72, and 64 can all be divided by 8 evenly. So what I want to do is I want to take that 8. Now, I also want to look to see if the variables have a common factor, and here they don't. In order for them to have a common factor, I would have to have at least one x in all three terms, which I don't. So it's just going to be an 8 that we factor out. And what I'm going to do is divide all the coefficients by 8. The 40 gets divided by 8, which gives us 5x squared. 72 divided by 8 gives us 9x, and 64 divided by 8 gives us 8. Now, what I would want to do at this point is make sure that the remaining coefficients don't have a common factor, or else I did not get the greatest common factor. 5, 9, and 8 don't share any common factors, so it looks like 8 was the greatest when I took that out. All right, and that's it. We're done. So all you have to do is find the greatest common factor, which is a little more difficult, but again, there's a video for that. And then once you do, you basically divide it out from the terms, or think of it as like undistributing. All right, so let's take a look at the second example. So here, our coefficients are -1, 6, and 12. They don't really have a greatest common factor other than 1, and they don't all have an x. So the reason I have this example here is because what we're going to be doing moving forward after the GCFs is factoring quadratics, and you don't want a negative x squared term when factoring quadratics. So when you have a quadratic like this, even if the only common factor is a 1, what you want to do is factor out a -1. Right, so you want to take a -1 out front. Now, I don't have to write the 1, so I'll just write it as a negative sign. And I'm basically going to divide all the terms by a negative sign or a -1, which changes their signs. So it becomes a positive x squared, a -6x, and a -12. Right, and now we have something that would be factorable inside the parentheses, maybe, right? But we don't want that negative out front. All right, and then here's another example. And again, I'm going to look at the coefficients 9, 18, and 81 and see whether or not they have a common factor. And it looks like 9 would be a common factor here. The first term is not negative, so I'm going to leave it as a positive 9. And when doing this, you'd probably want to make sure that it's in standard form, so biggest exponent to smallest, which we have here. And then I want to look. All the terms have an x. So I'm also going to include an x in my GCF, and then I want to take the smallest exponent that shows up, which is a square, or 2. And so I'm going to factor out a 9x squared. So I do this as 2 steps for each of the terms. I first divide the numbers, and then I subtract the exponents on the variables. So when I'm looking at this, I'm going to think, okay, 9 divided by 9 is 1. I don't actually have to write the 1. And then x to the 4th divided by x squared. When I look at the exponents, 4 minus 2 gives me an x squared. Right? So you subtract the exponents. And I go through and I do the next term. -18 divided by 9 is -2. And then 3 minus 2 is 1. But we don't write the 1, so we just leave it as an x. And then 81 divided by 9 is 9. And here 2 minus 2 is 0. Now when you get a 0 for the remaining exponent, you're just going to get rid of that variable. Right? X to the power of 0 is 1. 9 times 1 is just 9, so we're going to leave it like that. And there you go.